Hey, hi. If we have not met before, I am Priyanka Singh, and thanks for coming up till now here with me. Please do like, share, and subscribe my channel before going ahead. Today's question is unique paths. Here, a robot is located at the top left corner of a M cross N grid marked start in the diagram below. So this is the starting point of a robot which he has to cross um, this path. So here the robot can only move either down or right at any point in time. The robot is trying to reach the bottom right corner of the grid, marked finish in the diagram below. And we have to figure out how many possible unique paths are there. Okay, so for here, this is the starting point for for this given grid or matrix, you can say, and this is the finishing point where the robot has to reach, and we have to figure out how many possible paths are there. So this is since this is a small sample given to us, we can count on our hands, like this is one, then this would be two, then this would be three, all right, and the four, five, so likewise. Okay, so in this case, 3 cross 7 grid is given, and there are total 28 paths possible. For this 3 into 2, 3 outputs are possible. Okay, all right, and for this 28, this 6. So how are we going to do that? So if you see, what are we doing? uh, bef- uh, what are we doing? We are either our robot can move right or down, right? So at one point in time we will reduce its downwards, and one another time we will push it to rightwards. Okay, so how can we do that? So if whatever position we are, okay, so this is the row and another is the column, right? So if we want to push this our robot to the right hand side, then we can put one plus in the column, right? And another time what we will do is we can push its row by one. Okay, so and at the end, when it reaches to this finish point, at that point we will add one to our resultant, whatever variable that we are going to return with. And if it doesn't reach this finishing point, then we won't consider it as a valid path, and hence we won't sum it in our final result. Okay, so here, how can we do that? So very most simpler would be recursion, that I'm going to describe now. So we find at the end we just have to return. So what approach I'm going to use here is, either we can go from this place from left top corner to the bottom right corner, or we can start from here, this finishing point, and go back to this zeroth index. All right. So this is one way. So this is what I'm using. I'm using this recurse in reversing order, to just reduce usage of some extra variables. All right, so I'm whatever variable is given to me, I'm starting from that, and I'll be returning back to the zero. But since I'm starting this from m and n, I will expect it to reach 1 1 index instead of zeroth, since I'm starting off from this m and n. If a array is having 5 elements, then its last index would be at 4. But what are we doing here? We are taking it as 5, right? So this is what I'll be doing. Okay, so I'm expecting it to reach 1. If it reaches there, well, then I'll sum it up to my resultant before going ahead. Okay. So what I said before, according to that, I'll be no, from here. If I'm starting from this finishing point, either it will go up at a time or it will go left hand side at a time. So it will go up. That means its row will reduce by one, and if it goes right left hand side, that means its column will reduce by one. So that is what I'm doing here. So this is how it will consider all the permutation and combination of this matrix given. Okay, so this is it, and this would be another edge case where it reaches to zero. If any one of this reaches to zero, that means it's out of bound. Hence, I won't consider it as a valid part, and I'm not counting it in my resultant. All right. So this should give us. Let's check it. Run it. So this is for 3 and 7. 3 into 7, it's giving us the correct answer. Let's check for more use cases. 3 and 2, and then 7 and 3, and then 3 and 3. Alright, I'll run it for these use cases. So it seems well working for these, right? But as soon as I'll submit it, it will throw me a LTLE, that is time limit exceeded. Okay, so that is what it was giving me earlier when I submitted. So how can we, now the question is, how can we reduce it in terms of time complexity? So as you can see, there would be multiple cells there where we are which we are passing through multiple times, and every time we have to recalculate those values. So instead of recalculating, we can submit somewhere, we can save it somewhere and reuse it in future if it uses, right? So how can we do that? In that case, we would be needing we would be needing some value for each cell, right? So I would consider taking this matrix, okay, where we can save all those values. So what I'm doing for that, this would be again a recursive. So I'm making a unique path util here, okay, and we would be just calling this one here, and this util will call itself, not the other one. Alright, so this was our previous function, as you can see, right? So what I'm going to do here is I'll take uh, a new matrix that will save all the values for us. Okay, I'll call it grid. So I will call it grid, okay, and I will check for these two base cases, and then I'll check if my grid is having some value corresponding to these row and column. Okay, if this is not zero, that means it's having some calculated value that we calculated previously, and now we can make reuse of it. So in that case, I will just return this grid m and n, and won't be recomputing values for this. If it doesn't have any value corresponding to this, then in that case we can calculate it. Okay. So let's just give it a look, everything correct or not. So it seems perfect to me. Let's see how does it work for the given use cases. Um, Array dimension missing. So we have given the dimensions to this matrix. Now method uni. This cannot be applied to given type. This int new. Okay, so here we are missing something, which is grid. Here also we are missing something, grid. New int method cannot be applied to the given types. Okay, I missed to change this. Okay, so let's see. Array out of index. Okay, so here, as you know, if we are having an array of size 5, then its maximum index that we would be having would be 4. So hence we have to have one more, we have to increase it by 1 in order to make it work, because we are starting from the mth and nth index and taking it up to 1. Okay, instead of we have just make small shifting. Okay, nothing more. All right, so this has been accepted. So guys, if you will try to submit it, it will get accepted. That is what I did here. And first, when I was not using this dynamic program, this approach is dynamic programming, since I'm carrying this table to store pre-computed values and reusing it in my future computations. And if we are not going to use this, and if we are going to use my previous solution, then in that case we are going to have this time limit exceed. Okay, and this would work, this will get accepted. And in this case, if you guys have any query or any question regarding this, just do let me know in the comment box. Or else, if you have some better solution, better approach that people can understand easily and can retain it with them for a longer time, then please let me know. I would like to make a new video over it and share it with you all guys, so that it can be helpful. Thank you, and do like, share and subscribe my channel, and happy coding.